Hi guys, welcome to my YouTube channel Shivam Solution, and this is the problem this is numerical problem, and here we will solve this. First of all, the question is here: a sphere of mass 40 kg is attracted by another sphere of a mass 15 kg with a force of 9.8 into 10 to the power minus 7 Newton. Find the value of universal gravitational constant if the centers are 20 centimeters apart. This is our question. And see, whenever there is problem related with the two bodies and distance between their centers, we have read a formula that is there is Newton's law of gravitation, Newton universal law of gravitation, and by applying the formula of Newton laws of gravitation, we find the value of force of attraction between these two bodies. So first we will write we will go in a step by step. First we will write what is given in question. Here, mass of a sphere, we will take this mass of a sphere as mass 1 equal to 40 kg, and the second is mass of another here we have mass of another sphere, let's denote it by m2, equal to mass it is 15 kg. Now the force between them is, let's denote it by F, is 9.8 into 10 to the power minus 7 Newton, and we have to find universal gravitational constant, that is capital G. What? This is already given in our question, and we have to find the value of universal gravitational constant. Before doing this, please guys watch till the end, don't escape the video, you may miss some important point. So first we have to convert here, distance is given in centimeters, so we will convert this into meter, 20 centimeter, and when it will be divided by 100, we will get this into meter, 0.2 meter. Now we have to do, now we have already learned the formula of F equal to G mass 1 into mass 2 by d distance square. Here we have to find the value of capital G, universal gravitational constant. Mass 1 is this, and mass 2 and distance square, F. Now the force acting here is attracted is 9.8 into 10 to the power minus 11 Newton, and G is, we have to find the value of G, and mass 1 is 40 and mass 2 is 15, as we have already written here. Now distance square, distance between them is 0.2, and this will go in square. Now what we can do, we can easily multiply this with this force, or we can write G into 40 into 15 here equal to 0.2 square into 9.8 to the power minus 7 Newton. I hope you are understanding here. Now G equal to 3.3 This is, if we multiply this, we will get if we multiply this and this, we will get 3.92 into 10 to the power minus 8, and the down is, we will divide, we will get we will divide. Here we have written g, this multiplication, and this will go in divide, and we will get here 600. 1540 is 600, or g equal to, we will get here, if we divide this by this, we will get 6.5 into 10 to the power minus 11 nm square kg square, and that's the answer of the question. And this is our solution to the problem, and this is fourth related problem. This is of chapter 1. If you have any confusion, please comment. Hi guys, the next question is, a man can lift a mass of 200 kg on the surface of the earth. What is the amount of mass he can lift on the surface of the moon? This question is very interesting, and the solution is also very interesting. Look at the question, guys. This is, a man can lift, this is on the earth, and this is comparable, and there is discussion about the gravity value of small g on moon and the earth. We already know that the moon has that g is a small g value as 1.67 meter per second square, and the on earth that is 9.8 meter per second square in average. Now we will solve this problem. The question is asking, what is the amount of mass he can lift on the surface of the moon. First we have to solve here. We have to write here given. The best way to solve the problem is, first we have to write what is given in the question. Here the mass, we have to write mass of body on surface. What is it talking about? Then about the surface of the earth. Surface of earth, that is mass on earth is, can a person can lift 200 kg. Now acceleration due to gravity. What is the value of acceleration due to gravity on the surface of the earth? That is 9.8 meter per second square. Acceleration due to gravity on earth, will denote this by gravity on the earth, g equal to 9.8 meter per second square. Now weight. What is the weight of, what is the weight now? The weight is, now we know the formula of weight. To calculate the amount of mass it can lift on the surface of the moon, we have to first calculate the weight on the earth. Weight on the earth, so we have the formula of weight as weight equal to mass into gravity. So we are, as we are talking about the earth, so me denotation and g, and we will get it 200 into 9.8, and we will get here, if you type this and calculate, we will get 9060 Newton. This means the person the persons so emit this. Now we are talking about the on the moon, we have weight of on the surface of the earth is 9060 Newton. If a person lift 200 kg on the surface of the earth, the weight is 9060 Newton. And if the same weight is brought here on the moon, as here is acceleration due to gravity, acceleration due to gravity, as we are talking about moon, here is on the moon is 1.67 meter per second square. Mass can be lifted on moon. Mass can be will divide this equal to what we know, weight equal to mass into, and this is the formula of weight. Now what we have to find the mass which can be lifted on the surface of the moon. So we will write here mass on the moon is weight. What is the weight was? The weight was 80, and the gravity here is on the moon is 1.67 meter per second square. So mass will be here 1. If we type this in calculator, we will get 1173.65 kg. So this is the solution. If a man can lift 200 kg mass on the surface of the earth at the present of gravity 9.8 meter per second square, the same man can lift 1173.65 kg. As the gravity is less here, he will need a smaller force to uplift heavy things. So he can lift more on the moon than on the earth. The question seems interesting, as this is talked about the things which we can lift, and this is for a general knowledge also. This is very helpful. Thank you so much for what. Please watch and concentrate and see